Fifth question, integral x power n log x ds. The given function is x power n log x. Here we have two functions in product, x power n into log x. To integrate this, the power of n is positive. We can apply Bernoulli, but the power is not a fixed number. So it will not end with 0 at any of the point. So we can choose the formula integral udv equal to uv minus integral v du. Power is positive, but it is not a fixed number. So it will not end at a 0 at any of the derivative or any of the point. So we cannot go with a Bernoulli. You can choose this integral udv equal to uv minus integral v du formula. Here, order of priority given to isolate. So algebraic and logarithmic are appears. Algebraic and logarithmic. So logarithm is given priorities. So choose u equal to log x. U equal to log x. And the remaining is dv. Integral dv. Which is equal to integral udv. Integral udv. U is log x. The remaining are integral dv equal to integral x power n dx is integral dv. Now we need du, so differentiate this. Du by dx is equal to 1 by x. Then du equal to 1 by x dx. Du by dx is equal to 1 by x. Then du equal to 1 by x dx. Because we need a du here. U we have u. And then du we found. And then we need v. For that integrate dv. V equal to integral x power n means x power n plus 1 divided by n plus 1 plus c. So v is x power n plus 1 by n plus 1. This is integration. Integral dv means v. Integral x power n is x power n plus 1 by n plus 1. Here derivative du by dx is equal to 1 by x. Then du equal to 1 by x dx. Applying the above formula, integral udv equal to uv minus integral v du. We have integral udv equal to uv minus integral v du integral x power n log x dx is equal to product of u and v, x power n plus 1 which is equal to x power n plus 1 by n plus 1 x power n plus 1 by n plus 1 into log x or log x into x power n plus 1 by n plus 1 minus integral v du. V is x power n plus 1 by n plus 1 into du. Du is 1 by x dx into 1 by x dx. Look at here. We need not to integrate this. We have integral symbol here only. So integrating the second term, we have x power n plus 1 by n plus 1 into log x into minus the 1 plus n plus 1 by n plus 1 is constant taken out. Remaining are x power n plus 1 by x. Look at here. X power n plus 1 divided by x will be equal to x to the power n plus 1 into x to the power minus 1. Bringing this x to the numerator, it will be x power minus 1. The bases are equal, we can add the powers. Here x to the power n plus 1 minus 1, 1 minus 1 get cancelled. So n plus 1 minus 1, we will have x power n. So x power n plus 1 by x is nothing but x to the power n. So here x power n plus 1 by x will be equal to x power n. So x power n dx. uv minus the v du. 1 by n plus 1 is constant taken out. Remaining is x power n plus 1 into 1 by x. This 1 by x to the numerator minus x. When we multiply, the powers are added, n plus 1 minus 1. These two can get cancelled. Remaining is x power n. So the remaining is x power n into dx. Now integrating, the formula to integrate x power n is the first formula we have learnt in the exercise 2.1, that is x power n plus 1 divided by n plus 1 into log x equal to minus 1 by n plus 1 into integral of x power n is again x power n plus 1 divided by n plus 1 plus the constant of integration c. Now taking x power n plus 1 as common out, x power n plus 1 by n plus 1 as common, the remaining are log x then minus 1 by n plus 1 plus c is the answer for integral x power n log x dx. X power 5 e power x square is given. Question number 6 in the exercise of 5.2 dx. X power 5 e power x square. By the order of priority which is chosen as u, isolate. By use of isolate, give priority to choose u, that is algebraic, then exponential. So algebraic is the order of priority. So take u equal to x to the power 5. And remaining is e power x square. Look at the problem. We cannot go with directly to proceed. In this type of cases, first of all, we should give a substitution, because in the power we have one another function. There are two functions are in product, we can directly go with the formulas. Here, one another function is the power of exponential function. So in this case, we should simplify this problem, then we can enter into the formulas. Here, I am choosing with the substitution method here, choosing a substitution method. Substitute the power as t, put t equal to x square. That is by the change of variable, x square is taken as t here. Differentiate this. dt by dx is equal to 2x, then dt equal to 2x dx. But we need the value of dt here. Okay, t is x square, dt by dx is 2x, dt equal to 2x into dx. Then split the given problem. Integral x power 5 e power x square dx will be equal to, can simplify it more, integral, here we have x square, write in terms of x square as x power 5, x square whole square, that is x power 4, then what remains, one x is remain, so x into e power x square into dx. You can split the given problem into such a way, this is x square whole square, totally x power 4 here and one more x here, then e power x square into dx here. Now substituting t equal to x square in this, we will get integral x square is t, that is t square, and x square is t, here also we will substitute e power t, x square t square, so x square is t, t square is here, then here e power x square is t, e power t, the remaining are x into dx. X and dx are remaining. For that we should substitute from the result of dt. So dt divided by 2 implies x dx, which implies dt divided by 2 equal to x dx. This is a method of substitution. So substituting the power as x square as t, we get dt by dx is equal to 2x. Now dt equal to 2x into dx. We need the value of x dx here. So finding x dx by dt by 2 from the result. Substituting all these values in the above given equation. Changing this x power 5 x square whole square and into x and e power x square into dx. Here x square is taken as t, so this is t square, and here e power t, the remaining are x dx, so the x and dx are substituted by dt by 2. This is change of variable method. Now all the x terms are changed into t. Now look at the power of e is a single power, e power t only given. So this is t square e power t dt. We can take 1 by 2 as common. It will be equal to 1 by 2 integral t square e power t into dt. Instead of solving this, we can solve this one because both are equal. Here, this is in the form of x power in algebraic form, t power 2. And then the power is positive. So we can use Bernoulli formula here. 1 by 2 is common left out here. So taken this is u equal to t square, because by order of priority ILATE, exponent is at last, algebraic is in the middle, so algebraic function is taken as u, and the remaining are dt, u dv. So this is equal to 1 by 2, which implies 1 by 2 integral u dv. Here we have substituted for x is equal to t and then simplify the problem. Now this is in the form of integral u dv. Now we are choosing the formula of Bernoulli. Now u equal to t square. The remaining is integral dv, that is integral dv equal to integral e power t dt. U equal to t square and integral dv equal to remaining integral e power t dt. So u dash is equal to 2t, u double dash is equal to t, and u triple dash is equal to 0. If it is x square, 2x, 2. T square, so differentiate with respect to t here. So 2t and then 2 into 1, 2, then 2 is constant 0. So the third derivative becomes 0. Here integral dv is b, integral e power x dx is e power x, integral e power dt is also same e power t. Then b1 is equal to e power t, b2 equal to e power t, b3 also equal to e power t, because derivative of e power x is e power x always, and integral of e power t also e power t. So we have completed the terms which are required to apply in the formula. So we are moving here for the final answer 1 by 2 into the by Bernoulli formula. Write the formula here. Integral u dv equal to uv minus u dash v1 plus u double dash v2 minus etc. So equal to 1 by 2 into multiply uv t square e power t u dash v1 minus 2t e power t plus u double dash v2 2 e power t. The next term becomes 0, so left it plus c. So take out the constant common terms here. What are the common? E power t is the only term common from all the terms. So 1 by 2 e power t into remaining are t square minus 2t plus 2 plus c. Here substituting t equal to x square, because the given function in terms of x, we should answer also, our answer also in the terms of x should be given. So which is equal to 1 by 2 e to the power, instead t substitute x square, e power x square into t square, t equal to x square, t square is x power 4 minus 2 into t means minus 2 x square plus constant 2 plus the constant of integration c is the required answer. It will be asked in 5 marks. It's very important. Without substitution directly we cannot go with the answer. So first of all choose the function x square as t and then substitute in it, then reduce the function then t square e power t dt by 2, then take 1 by 2 out, 1 by 2 into t square e power t dt. This is in the form of integral u dv. Then you can choose the Bernoulli formula, you can apply it. And this is the last problem in the exercise of 5.2. We have completed 5.2. Now we can. Good morning all. Now we are entering to a new topic on another exercise. That is exercise 2.6. We have completed till 2.5 exercise 5. There are 5 exercises we have completed. Now we are moving to 6th exercise. Usually we have new formulas while entering to the new exercise, and here also we have some new formulas. Before entering new formulas, just recollect in your mind the formulas which are used in the first 5 exercises. After this 2.5, if we move to any exercise, we can use all the formulas, and at some of the places in between the problems the previous formulas are very must. So keep in mind always the formulas which are we have used in till the 5 exercises. Now here I am moving to exercise number 2.6. That is a new topic. I told you that integration by substitution or change of variable method. That method is known as integration by substitution, or it is known as change of variable method. It is also known as change of variable method. It is familiarly known as a substitution method. We have did 1 or 2 problems earlier for our easy purpose. I have used in the last exercise also by substituting t equal to some function taken t equal to x square. It has taken I think yes. For those type of problems is known as substitution method problems. When it is used, integrals of certain functions cannot be obtained directly because they are not in any one of the standard forms as discussed above. We have discussed many standard forms, that is integral sin x or integral cos x or integral secant square x. Like that we have discussed many problems till exercise number 2.5. Those typical cases they are not for they are all not following the certain standard form. We have reduced to bring it a standard form, then we have integrated. So those of the problems are known as not in standard form. Then we are converted into standard form, then we have applied. So those type of cases integration by substitution is used, but may be reduced to a standard form by suitable substitution. Directly we cannot the given problem will not be in the standard form. By substituting or by reducing, we can bring the given problem into a suitable standard form. So the substitution method is very useful to bring a complicated problem to bring an easy way. So the method of evaluating an integral by reducing it to a standard form by suitable substitution is called integration by substitution. Here the suitable substitution is very very important. We cannot substitute all the things. We should substitute suitable things to take the substitution. For that only you can complete the problem easily. You can easily understand by doing 1 or 2 problems. Now here I am going to introduce the formulas. Here for every exercise we have new formulas, and then in the similar manner here also we have some of the formulas I am going to introduce here. Look at here, I have written 5 formulas on the board. These are the new formulas we are going to apply in this exercise 2.6. The first one is integral f of x whole power n into f dash of x dx. The function within the power f of x to the power n, its derivative in product. While integrating, we can write it as f of x to the power n plus 1 by n plus 1 plus c. It is same as the exponent formula, but one derivative is appear here. That's all. Its derivative appears. When we integrate x power n plus 1 to n plus 1 plus c. Here f of x power n means f of x, comparing with the previous formula, f of x power n plus 1 to n plus 1. But in the integrand we should have its derivative also. Then we can go with the formula f of x power n plus 1 to n plus 1 plus c. Understand? Listen carefully here. F of x power n and its derivative in product. A function and its derivative. Function it has some power and its derivative are in product. Then we can go with the formula f of x power n plus 1 by n plus 1 plus c. Then look at the second one. Already we have applied this for two problems. It seems f dash of x by f of x dx is equal to, that means a function in the denominator and its derivative in the numerator. We can go with the formula log of modulus of denominator plus c. Okay, now move to third one. Here look at the second one. Both are similar, but we have only one difference, that is root in the denominator, that is root of f of x. Here f of x we have, here root of f of x we have. So look at the answers here, 2 times root of f of x. Okay, so the denominator has a root of the function, the numerator has the function's derivative. Then we can go with the formula 2 times the denominator. That's all. Here a function in the denominator, its derivative in the numerator, we can go log of modulus of the function. Here the function within the square root in the denominator, its derivative appears in the numerator. The function's derivative, not root of f. The function's derivative appears in the numerator. We can go with the formula 2 times root of the function plus c. And then the fourth one, look at here. F of x is the function, f dash of x derivative, both are in addition, and the whole value multiplied with e power x function. We can go with e power x into f of x plus c. We need not worry about this f dash of x, but it is in the form of e power x into function plus its derivative. In the form if it appears, you can go to e power x f of x plus c. Similar to the fourth one, look at the fifth one. This is very easy. Just a multiplied with x. That's all. The coefficient of x is 1 here. Other than coefficient of x appears, that is e power 2x, 3x, it may be anything. E power ax into a f of x plus f dash. This is similar to here, but a appears, a will be multiplied here. That is very important. So e power ax into a f of x plus f dash of x dx yields e power ax into f of x plus c. You can easily remember these formulas, I think. So these are the formulas that will be utilized in 2.6.